A sniper does not work alone. The standard element is two people, and the one behind the rifle is usually the junior of the pair. The spotter observes through a separate optic, calculates the firing solution, watches the bullet's path and its impact, maintains security, and handles communications. The shooter's job at the moment of the shot is narrow. Almost every decision leading up to it belongs to the other person. The two rotate positions during long observation periods. Sustained viewing through a magnified optic degrades visual acuity within about half an hour, so the rotation is a technical requirement rather than a matter of comfort. A team that stops rotating begins missing things it would otherwise have seen. That the job is mostly watching rather than shooting is reflected in how people are selected for it. Candidates arrive at sniper training already qualified as expert marksmen. Shooting is the entry requirement, not the subject of the course. Selection screens for vision, for psychological stability, and for a disciplinary record with nothing in it, because the role involves operating independently for days with almost no supervision. Attrition has historically run close to half, and most candidates who fail do not fail at shooting. They fail at fieldcraft, at observation, and at the patience the work demands. The central practical test is the stalk. A candidate must cross a long stretch of open ground over several hours, reach a firing position within a set distance of trained observers scanning with binoculars, and take a shot without being seen. The observers know someone is in front of them. They frequently still fail to find them. Movement is what the human eye detects, and a person who is not moving is very close to invisible, so the exercise is effectively a measurement of how slowly someone can advance. Concealment supports the same principle. A ghillie suit is built by the individual sniper rather than issued complete, and it is garnished with vegetation from the specific terrain the team will work in. Its purpose is not to make a person invisible. It is to break up the outline of a human body, because the brain identifies that shape before it identifies anything else. Modern concealment also has to account for thermal signature, since a body that cannot be seen is still warmer than the ground beneath it. Reaching the position is often the longest phase of a mission. A team may move for hours or across several nights, using terrain and vegetation and timing their movement to periods of poor visibility. In the final approach, progress is measured in meters per hour. Everything about the discipline follows from the same fact. Static objects are difficult to detect, and moving objects are not, so a team's primary defense is the near-total removal of movement from anything an observer could see. The final firing position is chosen for four things at once. It needs a view of the target area, concealment from observation, physical cover from incoming fire, and a route in and out that is itself concealed. Urban positions are built differently from what most people picture. Rather than firing from a window, a team sets up deep inside the room and fires through the opening from several meters back, so that neither the muzzle nor the shooter is visible from the street. Once the team is in position, the work begins and it is almost never shooting. Sniper teams spend the overwhelming majority of deployed time watching and reporting. They produce range cards, sector sketches, and detailed accounts of movement, routines, and changes in a location over time. A team can occupy a hide for days, fire nothing, and return having completed the mission successfully. The information is frequently worth more to a commander than any single shot would have been, which is the part of the job that almost no depiction of it gets right. When a team does engage, the target is selected for its effect on the enemy's ability to function rather than for being the closest or the easiest. Priority falls on leadership, on communications operators, on crew-served weapons and the people operating them, and on other snipers. Removing one radio operator degrades a unit more than removing several riflemen, and the sniper's real advantage is not accuracy, but the ability to choose which person to remove. What the team is holding depends on which of those targets they expect. Bolt-action rifles offer the greatest mechanical consistency and are used for precision at extended range. Semi-automatic rifles trade a small amount of that consistency for rapid follow-up shots and are used where multiple targets or shorter distances are expected. 50 caliber rifles serve a different function entirely. They are classified as anti-materiel weapons and are intended for equipment, vehicles, and structures rather than for people. Whichever weapon it is, the shot is a physics problem with several independent variables. A bullet begins falling the instant it leaves the barrel, and the drop grows steeply with distance. At 1,000 meters, the compensation required is measured in meters rather than centimeters. Time of flight matters just as much. Beyond that range, the bullet is in the air for more than a full second, which is long enough for a walking person to be somewhere the shot was not aimed. Distance has to be established before any of that can be calculated. Laser rangefinders are standard issue and return an exact figure instantly, but snipers are still trained in the manual method, which uses the apparent size of an object of known dimensions measured against the graduated scale in the scope. The old skill is retained for 3 reasons. A laser emission can be detected by the target. The device can fail or lose power, and some surfaces and angles return no reading at all. Wind is the hardest variable, because wind is not one thing. It varies in speed and direction along the entire path the bullet travels, and the team can only measure it where they are lying. Wind closest to the shooter matters most, because it acts on the bullet earliest, and the resulting deviation grows across everything that follows. Snipers read it indirectly, from mirage, from vegetation, from dust, and from the surface of water. At long range, a small error in that estimate is the whole difference between a hit and a miss. Air density determines how much resistance the bullet meets, and density shifts with temperature, altitude, humidity, and barometric pressure. A rifle zeroed in cold air at sea level does not shoot the same in thin, warm air at altitude. 2 further effects appear at long distance. The bullet's spin pushes it sideways, consistently in one direction, and the rotation of the Earth produces a measurable deflection beyond roughly 1,000 meters. Both are small. At extreme range, both are larger than the target. Because of all this, every sniper maintains a written record of every shot fired, the distance, the conditions, the corrections applied, and where the round actually landed. Manufacturing tolerances mean no 2 rifles behave identically, and ammunition from different production lots does not perform identically either. Published ballistic tables are approximations. The book is the verified truth for one specific rifle, firing one specific type of ammunition, and it is the reason a sniper's weapon is not interchangeable with anyone else's. With the distance measured, the wind read, the conditions accounted for, and the corrections taken from the book, the act of firing is deliberate, and each element of it removes a source of error. The rifle is positioned so that it points naturally at the target with no muscular effort because muscle tension shifts the aim as the shooter tires. The trigger is pressed during a natural pause in the breathing cycle. The position is held after the shot rather than released, both to avoid disturbing the rifle before the bullet has cleared the barrel and to observe the impact. Nearly the entire process is concerned with eliminating the shooter's own movement rather than with aiming. Leaving is the most dangerous phase of the mission, because the position is no longer unknown. The route out is planned before the position is ever occupied, and it is chosen on the assumption that the team will be moving under observation. The site is stripped of anything confirming that a team was there. The reasoning is straightforward. A firing position discovered after the fact can be used again. One discovered while it is occupied cannot be used at all. Finding a sniper from the other side is largely arithmetic. The angle at which a round strikes gives a line back toward its origin. Acoustic sensors triangulate the sound of the shot. Analysts then identify every location with a line of sight to the point of impact and reduce the list from there. And counter-sniper teams watch those specific positions rather than the area in general. This is also why sniper doctrine treats a second shot from the same position as a significant risk rather than a routine action. Everything described so far applies at distances where the variables are difficult but manageable. At the outer edge of what has actually been done, they stop being manageable at all. The longest confirmed engagements sit beyond 3,000 meters, with a publicly reported record set in Iraq in 2017 at roughly 3.5 kilometers. At that distance, the bullet is in flight for close to 10 seconds. The wind has to be estimated across terrain the team cannot see. The drop is measured in tens of meters, and the target has 10 full seconds in which to move somewhere else. Shots at that range are not marksmanship in any ordinary sense. They are a calculation, and a substantial part of the outcome is chance. Thanks for watching. Which part of the job surprised you most? Drop it in the comments. Also, please remember to like and subscribe if you enjoyed this video.